All right, so here we are with topic number 2, applications of the fundamental counting principle and factorial notation. Factorials. Let's all put an exclamation mark for that because when we do factorials, you'll know why. Exclamation. So let's explore this idea. How many different arrangements of children can be created for a lineup? So what we're going to do is we're going to apply the fundamental counting principle as well as factorial notation. So that's the new topic. And we're going to use factorial notation to represent fundamental counting principle problems. The following 6 children are forming a line to wait their turn at the water fountain. Question number 1 says, create one possible arrangement of the 6 children. Well, technically we have one arrangement if we have a fountain over here. So here's our water fountain. Okay, Frank's in the front, then Eva, then Devinder, Chandeep, Brandon, and Anna. We can create a different one. We could have Anna, Eva, Brandon, Devinder, Frank. Did I get them all? No, and Chandeep. So we've got quite a few ways. There's a lot of different ways we can arrange it, right? Explain why the product 6 times 6 times 6 equals 46,645 would not be correct. So think about that. Why would that not be correct? I'll let you think. You can pause it and think. And I'm going to tell you why. Only one of each child, so they can only be in line once. So once that child has their position, they can't be repeated. We can't have Anna going back. So we can't do 6 times 6 times 6 times 6 times 6 times 6. Because once Anna has her drink, she's done. She doesn't get to go line up again. Okay? Determine the number of arrangements that the following 6 children could form while lining up to drink from the water fountain. So if we use our fundamental counting principle, we think about that. The first kid to line up, there are 6 options, right? Because it can be any of the 6. Now, one of them has taken a drink. So the second, there are only 5 kids left to have a drink. So there's only 5 options. The third, 2 kids have had a drink. So there's only 4 left. The fourth, 3 kids have had a drink. So there's only 3 left. The fifth, 4 kids have had a drink. So there's only 2 left. And then there's only 1 child left. We don't know which child is in which position, but there are only that many options left. So when we multiply those, we get 720 options for how they can line up. Okay? Now, we can use factorials to help us do this. Now, what a factorial is and we're going to use our technology, and I'll also make a little video showing you how this works on your calculator. To perform it, however, on the TI-84, you press Math, and then you select the PRB menu, and you choose 4 to select 4, which is the factorial. So you type in 6, choose Math, etc. And like I said, I will do another mini video to show you how to do factorials on your calculator so you can see it. So this is why I wrote that exclamation mark. This is a factorial. So when we do that and when we put it in your calculator, basically what a 6 factorial is it's equal to 6 times 5 times 4 times 3 times 2 times 1. And when you type that in your calculator, you will get 720. Okay? So any factorial, that's how it lays out, right? So 5 factorial would be 5 times 4 times 3 times 2 times 1. And we can figure that out. That would equal, if you try it on your calculator, 120. Okay, now if it's got 5 times 4 times 3, 5 times 4 times 3 times 2 times 1, you get 120. But imagine if you wanted to figure out 100 factorial. You do not want to be punching all those numbers in your calculator. However, you can use your calculator and you push the math button and then you choose PRB and 4 and you can get that number and it's too big. So let's not do 100 factorial. Let's just do 14 factorial. Even that is going to be challenging, right? Because that gives me 8.7 times 10 to the exponent 10. So that's a huge number, okay? 7 factorial, again, so your calculator is going to do a lot of that work for you, okay? But you do need to know how to use that on your calculator, okay? Now, factorial notation, and I think I've talked about it, it's a short way of writing the product of consecutive descending whole numbers. So like I said, 5 times 4 times 3 times 2 times 1. So we're consecutive, we're going down by 1, and we're whole numbers, so there's no negatives, and there are no fractions or decimals. They're whole numbers, okay? So we're dealing with those numbers. And this would be the formula for factorials. The n factorial is equal to n times n minus 1 times n minus 2 times ... till you get down to 3 times 2 times 1. Okay? And isn't that beautiful that your calculator can help you out with that? Okay. So let's use this. How many ways can 9 football players line up in the array shown on the right? So we have our array on the right. So it's basically we have the 9 football players and they're going to keep switching positions. So we could do 9 times 8 times 7 times ... times 3 times 2 times 1 to get our number. Or we can use 9 factorial. So we're going to put in our 9. We're going to hit the math button. We're going to arrow over to PRB, and then we're going to select 4, which is the factorial. Then we should see on our screen 9 factorial. Hit enter, and you should get 362,880. That's a lot of different ways that you would position them. Now, let's look at another example with some restrictions. If the team captain, Daryl, must be in the middle for a photograph. So Daryl is the team captain, and he's got to be right in the middle. So I don't know if you can see how I'm highlighting that. It might be easier just to do that, right? Daryl's got to be in that middle position. So all the other positions can be filled by the remaining 8 players. What that means is that we take that 1 out, right? So what we have is, we have 1 for Daryl times 8 times 7 times 6, all the way down, times 3 times 2 times 1. So it's 1 times 8 factorial. So put that in your calculator, hit your 8, hit your math button, scroll over to PRB, and hit 4. So 1 times 40,320, which is 40,320. So Daryl limits our choices quite a bit, okay? Now, to determine the fastest 3 players, all 9 players decide to race across the field. How many different arrangements are possible for first place, second place, and third place? So let's look at this one. We've got the 9 players. We want to know who's fast. So we're looking at first, sorry, I used the wrong pen. I want my nice highlighter. first place, second place, and third place, but there are 9 players. Okay, so we want to know who the first 3 are. So on the one end, we could have 9 possibilities for first place. So this is for first place. Now one person won first place, so there are only 8 left. So this is for second place. And then for third place, we just have 7 left. Now, we don't care in this question who gets 4th, 5th, and 6th. We just want to know who are the top 3. So we are just going to multiply, using our fundamental counting principle, multiply 9 times 8 times 7, which works out to 504. Okay? Now, we're going to do some stuff with some factorial calculations. So there's some interesting things that happen when we divide factorials by factorials. Okay? And we can think about them by mapping them out. So looking here, if I have 8 factorial divided by 6 factorial, so that would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's a weird time, so I'm going to fix it. That's on the top. On the bottom, it would be 6 times 5 times 4 times 3 times 2 times 1. Now you notice where I wrote it, because what we notice is these match up, these match up, these match up, these match up, these and these match up. So they're all going to divide out of the top and the bottom. So all I'm left with is 8 times 7, which is 56. Okay, now you can do this on your calculator. You can go 8 math factorial divided by 6 math factorial, and you should get 56. So on your calculator, you can select those and do those divisions as well. Okay, so you can use your calculator to help you these. But here's the other thing. I don't need to write all this out when I'm thinking about it. I can write 10 times 9 times 8 times 7 factorial, right? Because that's 7 factorial would be 7 times 6 times 5 times, etc. all over 7 factorial. These are the same, so they divide out. So I'm left with 10 times 9 times 8, which when I multiply, I get 720. So however you want to do it, if you want to stick 10 factorial divided by 7 factorial in your calculator, you can do that. Or you can just think to yourself, well, wait a minute, if I remove the 7 factorial from my 10 factorial, what is left over? Okay? Alrighty. So let's keep going here. A school librarian is arranging a display of 10 books in the school onto shelving. So we've got 10 books there. How many arrangements would be possible if the 10 books are arranged in alphabetical order on the shelf? Well, there's only one possible way to put things in alphabetical order because there's only one alphabet. So there would be only one possible way to do that. How many arrangements would be possible if the 5 non-fiction books must be organized on the top shelf and the 5 fiction books on the bottom shelf? So I've split them up 5 and 5. I've given no other criteria, just you can arrange them any ways. So on the top shelf, it would be 5 factorial, because there's put 1 in, then the second, then the third, then the fourth, then the fifth, so 5 factorial. So this would be the top. And then on the bottom shelf, I'd also have 5 factorial. So if I multiply those, and I can use my calculator, 5 math PRB, choose factorial, times 5 math PRB, oops, I gotta do that again. Sorry, I punched the wrong number. So 5 factorial times 5 factorial gives me 14,400 different ways to arrange those books. You wouldn't think it, eh? You just look at, all I got is 10 books here. That's how many ways I can arrange it? Really, indeed. How many arrangements would be possible if the 3 favorite books must be organized on the top shelf and the other 7 on the bottom shelf? And you can see how it's helpful to have a picture, because I have 3 here, that's 3 factorial, and I have 7 here, 7 factorial. So 3 factorial on the top times 7 factorial on the bottom. And when I put those in, I'm going to get 30,240. Now, if you don't like using your calculator, you can write that out. The first one would be 3 times 2 times 1. Again, I wrote weird letters. And then it's times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that gives you your answer. Okay, those are just the ways to write that. Well, that's our introduction to factorials notation. Let's just look at our need to know, so kind of make sure, overview, that we talked about it. The expression n exclamation mark is called n factorial. N factorial represents the number of arrangements in a set of n different objects. And that's how you would write that out. N factorial is n times n minus 1 times n minus 2, all the way down till you get to 3 times 2 times 1. Okay? If all objects in a group need to be arranged, then factorial notation can be used instead of the fundamental counting principle. And basically, it's just going to save you a little work. Your calculator is going to do some work for you. So we have some practice questions